Hello, this is the final part 5 of integral chapter test. So let's just continue on. So on 32, we have the integrals from 1 to infinity of tan inverse of x over x squared of dx. So yeah, it looks like it's an improper integral based on the boundaries from 1 to infinity. So we have an improper integral. So what we're going to do is, just like the last one, what we're going to do is we're going to set it up as the limit as a approaches infinity. And then we're going to replace infinity with a. So it's going to be 1 to a of tan inverse of x over x squared times dx. Oops, you don't need this extra one. And how are we going to take the integral of this? Tan inverse of x squared. It's not a u substitution. Yeah, it's not a u substitution. It's I'm going to say integration by parts. Okay, so let's figure out our u and our v, or dv. Our u is the tan inverse of x, and my dv is a leftover. So it's 1, your leftover is 1 over x squared of dx. And then my du, the derivative of tan inverse of x is 1 over 1 plus x squared dx. And my v is the integral of 1 over x squared dx. Okay. And continuing on, the integration of 1 over x squared is the same thing as x to the negative 2 dx. And you know how to take the integral of that. It's just whole power plus 1 over negative 1. So that's just going to be, v is going to be negative 1 over x. Okay, so now you apply the integration by part rule. So it's uv minus the integration of v du. So you're going to set it up as the limit as a approaches infinity. And then your u is tan inverse of x times my v, which is negative 1 over x, minus the integration of v du. So my v is negative 1 over x, and my du is 1 over 1 plus x squared dx. Okay, so what can we do? Okay, so we'll simplify this. Over here we have two minuses, so we know that's going to be a plus. And then we'll just bring this together. So what's this times this? It's just 1 over x times 1 plus x squared of dx. And then this is still the limit as a approaches infinity. And then you have negative tan inverse of negative 1 to the x over x. Okay, so what can we do now? So let's look at this part right here. The integration of 1 over x parentheses 1 plus x squared dx. How would we take the integration of that? If you said partial fraction decomposition, that's correct. We're going to take the integration by using the partial fraction. Decomposition. let's do that. Let's simplify this. So this is going to be 1 over x times 1 plus x squared equals a over x plus bx plus c over 1 plus x squared, right? Because the derivative of x squared plus 1 is a linear line, the derivative of x is a constant. So that's why I put in a, and this is why I put it bx plus c. Then what I would do is get rid of the fraction by multiplying both sides by the LCD. And the LCD is x times 1 plus x squared. So times this by this, that gives you 1. And then over here, when you multiply this out, you get a times 1 plus x squared. Over here, when you multiply this out, what cancels? So if you multiply this, the 1 plus x squared cancels, you're left with bx plus c times it by x. Okay, so clean this up. So it's 1 equals, and then FOIL this out. This is a plus ax squared. And then bx times x, that's bx squared. And then c times x is cx. And then what you're going to do is kind of like line them up. So yeah, collect like terms. You have an ax squared plus bx squared. Well, that's the same thing as a plus b x squared, right? Because if you it's the same thing as ax squared plus bx squared, and then you can collect out like an x squared, right? Plus a cx plus a. And then you just kind of like group them. So we know that on the left side, there's no x squared. It's like a 0x squared, and then a 0x, and then you have a constant 1. So you kind of line them up. A plus b x squared goes with 0. So you could say 0 equals a plus b. And then cx equals to 0 because there's no x. So it's going to be 0 equals c. And then this 1a equals to 1. So you already have one value, a equals 1. We find b, yes. So if I plug in a with 1, and then if I subtract 1, I get b equals to 0. Oops, I'm sorry, my mistake. Why is this a 1? This should be a 0. So it's actually -1. So b equals to -1, and c is equal to 0. So we have our a and our b and our c. So we can start simplifying. We're going to set it up like the limit as a approaches infinity. Okay, and then we have our a and our b, so we can just set it up like this. A is 1, so it's going to be 1 over x, plus b is, what's my b? My b was -1, so it's going to be -1x plus 0 over x squared plus 1 d of x. So you're going to set it up as this. Negative tan inverse of x over x of dx plus the integration of 1 over x dx plus the integration of negative x or 1 plus x squared dx, right? Okay. But this one is easy. What's the integration of 1 over x? It is ln of absolute value of x, right? This one is okay. What's the integration of negative x over 1 plus x squared? We'd use u substitution, right? And then my du is going to be the derivative of 1 is 0, the derivative of x squared is 2x dx. And well, you have a minus here. Let's take that out. So that's going to be a minus. And then we don't need this 2 here, so we have to get rid of it by multiplying both sides by 1/2, right? It's 1/2 du, and then this is 2 times 1/2. The 2's cancel, so you're left with x dx. And so you can write this as the minus integration of u, and then you can replace x dx with 1/2 du. 1/2 is a constant, so put that in front. And then what's the integration of 1 over u? It's ln. So it's the ln of u, which is really just 1 plus x squared. And then we have this negative 1/2. And then we bring down this ln of absolute value of x. And then it's going to be the limit as a approaches infinity. And then this stays the same, negative tan inverse of x for x. And then we're going to go from 1 to 9. And then you just don't to a, sorry. That's not a 9, that's an 8. And then you apply the upper minus the lower, right? So that's going to be the limit as a approaches infinity of negative tan inverse of a for a plus ln of absolute value of a minus 1/2 ln of absolute value of 1 plus a squared minus bracket negative tan inverse of 1 over 1 plus ln of 1 minus 1/2 ln of 1 plus 1 square. And that's going to give you and then let's see the tan, so it's minus, and we know that the tan inverse of 1 is pi over 4, and then there's a minus, so it's going to be a negative and negative, positive. And then the ln of 1 is 0. So so I'm distributing this minus, so the ln is 0, and then so it's a minus 0. And then it's negative and a negative, so that becomes positive ln of 2. So if you recall, because we're dealing with limits, if you recall the tan inverse graph would look something like this. It has two boundaries. It has one at pi over 2 and then negative pi over 2. And then you have this graph y equals ln of x. And then, so when you put the limit, it's going to be negative pi over 2 over infinity plus ln of infinity minus 1/2 ln of infinity plus pi over 4 plus 1/2 ln of 2. And that gives you pi over 4 plus 1/2 ln of 2. Because I believe that ln infinity just cancels, right? So you're left with, oh wait. Yeah, so you're left with pi over 4 plus 1/2 ln of 2. Okay, so this one was kind of difficult because you did an improper integral and then you had to do integration by parts. Okay, let's move on. Let's do a word problem. So number 3 says the acceleration of at of a body moving in a straight line is given in terms of time as t, as a of t equals cosine of 2t. If the velocity of the body is 2 at t equals 4, and if st is the distance of the body from the origin at the time t, what is s of pi minus s of pi over 2? So it's like an integral. It's really saying s of t from pi over 2 to pi of vt. They give you, what do they give you? They give you v of pi over 4 at 2. So really you have a coordinate at v of pi over 4 of 2. So that means your v of t is 2 plus the integration from pi over 4 to t, and your vt is so vt is your at, which is cosine of 2t. And then we can simplify this. So yeah, let's find vt. So this is 2 plus, and then what's the integration of cosine of 2t? Well, the integration of cosine is sine of 2t, and then it's then you bring down this 1/2, right? And it's from pi over 4 to t. So you get 2 plus, and if you apply the fundamental theorem, it's going to be 1/2 sine of 2t minus 1/2 of sine of 2 times pi over 4. And you get v of t equals 2 plus 1/2 sine of 2t minus 1/2 of sine of pi over 2. And then you get v of t equals 2 plus 1/2 sine of 2t, and then minus 1/2, and then sine of pi over 2 is 1. So that means my vt function is 3/2, because 2 plus negative 1/2 is 3/2 plus 1/2 sine of 2t. So step 2, find s to t. So s to t is, we're going to set up from pi over 2 to pi over 2 to pi. And then it's just the integration of v to t, which is this. Okay, so then what I would do next is take the integration. So the integration of 3/2 is 3/2 t. The integration of 1/2 sine of 2t is, so 1/2 is a constant, so it's going to be 1/2, and then it's going to be a negative 1/2 cosine of 2t from the boundaries pi over 2 to pi. So it's going to be, so it's going to be 3/2 pi plus negative 1/4. So I'm applying the fundamental theorem. Cosine of 2 pi minus bracket 3/2 pi over 2 minus 1/4 of cosine of 2 pi over 2. This is going to be 3 pi over 2 minus 1/4 times 1 minus 3 pi over 4 plus 1/4 times negative 1. When you simplify this, this is going to be 3 pi over 2 minus 1/4 minus 3 pi over 4 minus 1/4. And then when you're adding, subtracting fraction, you need an LCD. So if you look at the bottom, we have a 2, 4, 4, 4. Looks like my LCD will be 4. So I'm going to multiply top and bottom by 2. So that's going to be 6 pi minus 1 minus 3 pi minus 1 all over 4. So your final answer is 3 pi minus 2 over 4. Okay, let's move on to 34. So number 34 says, find the average value of f of x of e of raised to the square root of x all over 2 square root of x on the intervals 1 to 4. So when they say find the average value, you're going to use this formula, 1 over b minus a from the integrals a to b of f of x d of x, right? So if we're going from the boundaries 1 to 4, that means a is 1 and b is 4. So it's going to be 1 over 4 minus 1. And then it's going to be from 1 to 4 of e to the square root of x over 2 square root of x d of x. And then this simplifies as 1 over 3 from 1 to 4. And how are we going to take the integration of this? Yes, I think we're going to have to do u substitution. And I think our u is going to be radical x. So my du, what is the derivative of square root of x? It's 1 over 2 square root of x of d of x. Comes out nicely, right? We don't need to take out anything. It's good. So it's going to be e to the u. And then you can replace 1 over 2 square root of x dx. So you can replace this whole thing with du. And then we can change our boundaries if you like. So if x equals 1, your u is going to be square root of 1, which is 1. And if x equals to 4, my u is going to be square root of 4, which is 2. So let's change our boundaries from 1 to 2, and then we have 1/3, and then you have e to the u du. And then what's the integration of e to the u? It's just e to the u. So it's going to be 1/3 e to the u from the boundaries 1 to 2. So that is going to be 1/3 e squared minus e to the 1. And I think that's it. We can't go any further, so this is our final answer. Okay, let's move on to 35. 35 is our last one. Yeah, 35 is definitely our last one. Okay, 35 says find the value of c that satisfies the mean value theorem of for the integrals for f of x equals x minus x squared on the intervals 0 to 1. Find the value of c of the mean value theorem. So when they say that, I automatically know I can set it up like this. It's going to be f of c equals 1 over b minus a from the integrals of a to b of f of x d of x, right? So we know that f of c is called the height, and we know that b minus a is the width. So it's going to be 1 over, and then b minus a, so that's 1 minus 0 from the integral 0 to 1. And our f of x is given, x minus x squared d of x. So that means f of x is going to equal to 1 over 1 minus 0 is just 1. And then now this one's easy. How do you take the integral of these? You can just take it individually. So what's the integral of x? It's going to be x squared over 2. What's the integration of negative x squared? It's negative x cubed over 3. And then we're going to go from 0 to 1. So now you just apply fundamentals. So this is going to be 1/2. Well, 1 squared is 1, so that's 1/2 minus, and then 1 cubed is 1, so that's 1/3 minus, and then when you plug in your 0, it's 0 minus 0. So 1/3 minus 1/2 minus 1/3 is 1/6. So f of x equals to 1/6. But that's not our answer. That means so if f of x equals 1/6, what does that mean? It means that your f of x, which is x minus x squared, equals to 1/6. And then you go ahead and try to solve for x. So we have a fraction. So to just get rid of the fraction, we're going to multiply all 3 sides by the LCD. So we have a 1, 1, 6. So my LCD is 6. Go ahead and FOIL out that 6. So this is going to be 6x minus 6x squared. And then 6 times 1/6 is 1. And we'll probably get a factor, so we got to get one side 0. So maybe we can move everything to the right. Cancels, you're left with 0 equals to, let's put this from highest order to lowest. And yikes, it doesn't factor nicely. Even if I try bottoms up, it will not work. So if it doesn't factor, we use the quadratic. So a is -6, b is, oops. Yeah, a is 6 and b is -6 and c is 1. So x is opposite of b, which is 6, plus or minus root. B squared, I know that's 36, minus 4 times a, which is 6. C is 1, all over 2a. So that's x equals 6 plus or minus that. That is 36 minus 4 times 6 times 1, that's 12. All over 12. And when you simplify it, so square root of 12 can be fixed. And when you simplify it, you're going to get x equals 3 plus or minus radical 3 all over 6. So this is our c value. So you could say c equals 3 plus or minus radical 3 all over 6. Now, can we use both values? I think so, because if you do 3 plus radical 3 over 6, that's about 5 over 6. And then 3 minus radical 3 over 6 is about 1/6. That's technically in our boundaries, right? Our boundaries from 0 to 1. So yeah, this means we have two c values, and this is our final answer. Okay, I'm going to stop here. That's the last problem for the integration test. So go ahead and review these integration tests, and you should be good. Right. You should be good for all kinds of integral problems for your next upcoming exam.